Hey, hello everyone. Welcome to the lecture number 1, classification of transmission line, which is based on the module performance of transmission line. Myself Ganesh, assistant professor in electrical engineering at KK Institute of Engineering Education and Research, Nashik. So today we are going to discuss the classification of the transmission line. Let's see what are the contents of the today's session. Introduction to the transmission system in India, then classification of the transmission line, classification of the transmission line based on the voltage level, classification of the transmission line based on the line length, and last one we will see the summary. So let's begin with the learning outcomes of the today's session. Okay. So at the end of this session, the learner will be able to classify the transmission line based on the voltage levels. Then justify the RLC parameters used in the transmission representation based on their classification. So let's begin with the transmission system in India. So we know that the generating stations are dispersed and away from the load centers. So we will take an example of Maharashtra over here. Okay, so as I am from the Maharashtra, I am taking the example from Maharashtra. So the majority of the generating stations are thermal in nature and which are located in the Vidarbha and Marathwada. And if we compare the load center, majority of the consumers are in the area of western side of the Maharashtra. Okay, western side of Maharashtra means load center is very away. If we check, the load center is very away from your generating stations. So it is necessary to transfer this bulk amount of the power from generating stations to the load centers. So how we can transmit this power? So for the transmission of this power, it is necessary to have a link between them, which is called as transmission system. Okay, so which is called as the transmission system. So transmission system is a very important part in this case. So transmission the transmission system facilitates the evacuation of the power from generating station to the load center, as we seen in the previous diagram. According to report of CEA, what is a CEA? CEA stands for Central Electricity Authority. Okay, so this is the government. This is the authority which is formed by the government of India. You can refer the website of CEA.ac. Okay, cea.ac.in. So you can have this all details on this CEA website related to your electricity. So according to them, the total transmission network in India is 15,791 kilometer. How much? 15,791 circuit kilometer. Out of that, 5,889 is owned by the central government. 7,964 is owned circuit kilometer is owned by the states, and 1938 are owned by the private sectors. Okay, circuit kilometers. So here we are seeing that one important word. What is this circuit kilometer stands for? So let's see what is this circuit kilometers. Okay, so to understand the circuit kilometer, I will take on the dashboard. Okay, so I will explain it on dashboard. Let us consider that I have a single phase line. In this single phase line, I am using the phase for the transmission of the power from one end to the load center. Okay, and these two terminals are ground, means ground is acting like a return conductor. Suppose this total length is of 2 kilometer, then this circuit kilometer is 2 circuit kilometer because it is a single phase with the single conductor. Okay, so this is the 2 circuit kilometer line. But suppose I have a single phase line with one as the going towards the load center and another working as a return conductor, another is working as a return conductor, then this line is called as the length is again same, the length is 2 kilometer, but physical length is a 2 kilometer, but in terms of circuit kilometer this is known as 4 circuit kilometer, is 4 circuit kilometer. Okay, in the three-phase line, okay, suppose we have a three-phase line. Okay, so total physical length is of 2 kilometer, then it is called as a 6 circuit kilometer. Okay, so suppose we have a three-phase double circuit line. So we know that the three-phase double circuit lines, many times you see such towers, that on this tower you will observe that this is the three-phase line. Okay, so this is the three-phase structure. On this side also there is a three-phase structure. Okay, so this is carrying the conductor. This is the double circuit transmission line. Okay, this is three phases. These are the three phases. Okay, so total and in this case the total kilometer is considered as the 12 circuit kilometer. Okay, so please understand this terminology, circuit kilometer. Okay, so this is very important term in the power system. Okay, so according to CA, such network is a 15,791 circuit kilometer. So let's see on the map. Okay, oh, what is this? Yeah, oh, you can see that this is plan up to the 2015. So if you see in India there is a huge network of the transmission line, and this is all is showing the transmission line network, but what is it is above 400 kV, not below 400 kV. Such a huge network is there. So let me zoom somewhat so that I'm magnifying, so you can observe that the lots of the transmission lines are existing in the India. Okay, so just like your road. Okay, so these are the transmission line which are available in India. So we know that this is another one good sector to work as electrical engineer. Okay, so but how will work? Okay, without understanding the concept, how will work in that area? So let's begin with the transmission line parameters. In the second year we have studied how to calculate the transmission line parameters. So obviously the transmission line is made up with the metal. Okay, so that is the conducting material. So conducting material have its own resistance. Depending upon the configuration of the transmission line, we have inductance. Again, we have a capacitance with respect to ground. Okay, and we have a shunt conductance also. Okay, so how this will be formed here, that we will see. So transmission, the first parameter is the series parameter. Transmission line are, okay, so the transmission line are made up with the metal. So every metal have its own resistance. So this resistance is, okay, so this resistance is distributed over the entire length. Okay, distributed over the entire length. Suppose I have this transmission line. So this resistance which I am showing here, it is in lumped form. This is distributed through the entire length in the transmission line. Okay, so again, how to calculate this? We know that the simple formula R is equal to rho L by A, where rho stands for the resistivity, L is the length of the transmission line, and A is the cross section area of the conductor. So by using this formula we can calculate the value of the resistance. And suppose we want to consider the effect of temperature, again the value of the resistance will be changed. So what is the effect of temperature on the resistance of the conducting material? As the temperature increases, resistance also increases. We have already studied in the first year. Let's begin with the inductance. Inductance is also a series element, and it is formed due to the internal and external flux linkage. Every conductor, so let me draw a cross section. Every conductor carrying a current produces its own magnetic field, and that flux is linked with the conductor as well as it is linked with the outside. Okay, extra. So internal and external, it affects the internal, it affects the internal flux, also external flux. Okay, so suppose two conductors are there, then they have a two flux linkage. One is the internal flux linkage and one is the external flux linkage. So due to this internal and flux linkage, we have studied that about the calculation of the inductance. So what is the formula of that inductance? L is equal to 2 into 10 raised to minus 7 GMD upon GMR. Hope you remember the concept of GMD and GMR. Suppose we have three conductors, okay, and they are equally spaced by the d meter, then its geometrical mean distance is given by, GMD is given by cube root of d into d into d. So in this case it is equilaterally spaced. Suppose this is a d1, this is a d2, this is a d3. Suppose d1, d2, d3, then this is a GMD. How to calculate the GMR? There is in one phase there is only one conductor, so that in this case GMR is 0.7788 times of r. Okay, so r is the nothing but the radius of the conductor in a three-phase line. So for a double circuit it may be the different. So GMR is geometric mean radius. Okay, so geometric mean distance and geometric radius, we have already studied this in the second year. Okay, so let's begin with, this is the internal flux linkage. This is due to the internal flux linkage, the inductance will be formed. Then capacitance, the capacitance will be formed, the transmission line. Okay, so these are the two metals, and in between these two metals there is area. So two conducting plates, and in between air is the insulating material, so it will form a capacitance. As it will form a capacitance means every two lines have its own capacitance in between. Okay, it will form a capacitance. Also, this will form a capacitance with respect to ground, because ground is also one conducting material. So two conducting material, in between there is air, so each ground, this will form capacitance with respect to the ground. So these are all are the shunt element, that is the shunt connected. Again, it is distributed over the entire length. Okay, so every time this word is common, it is a distributed parameters, not the lumped parameters. But for analysis purpose, what we will do, we'll see. Okay, so it is calculated as Cn with capacitance with respect to ground or with respect to neutral is 1 upon 18 natural log of GMD upon GMR microfarad per kilometer. Okay, so this is the value of the capacitance. Okay, conductance is the shunt conductance formed between the conductors and conductor to grounds. Okay, so air is not a perfect insulating material, it has its own resistance. So this shunt resistance, 1 upon this shunt resistance will give you the conductance, and for modeling purpose we can take the capacitance and the conductance in parallel. So we have two parameters. So these are the series elements which is given as a Z, that is given as R plus J omega L, and these are the shunt element which is in form of admittance, it is given by G plus J omega C. Okay, G plus J omega C, or Y is also taken as G plus JB. Okay, G plus JB. So according to this, we have seen that transmission line has a four parameters: resistance, inductance, capacitance, and conductance. Okay, so let's begin to the next. How then classify this transmission line? Classification of the transmission line is based on the two main aspects. One is the voltage level and another one is the length of the transmission line. So according to the voltage level, so there are the 5 categories according to the voltage level, and according to Indian standard, the low voltage transmission line, okay, LV, it is also abbreviated as LV, low voltage transmission line, the transmission line having the voltage below 1 kilovolt is known as the low voltage transmission line, and this is used for the secondary distribution. Okay, so this is used for secondary distribution mainly. So we know that in our home we have a supply of 230 volt single phase. This is under the low voltage category. In your premises there may be 440 volt 3-phase supply. This is also come in the category of low voltage supply. This is also come in the category of low voltage supply. Okay, So the next level is what? Medium voltage. The medium voltage lies between the 1 kilovolt to the 69 kilovolt, and this is used for a primary distribution. If you look outside to your building, you might have be observed that the pole mounted substation, pole mounted substation is designed for 11 kV by 440 volt, 3 phase 4 wire supply. Okay, so that 11 kV supply is only used for primary distribution. So 11 kV, 33 kV, 66 kV, these are used for primary distribution purpose. Okay, so these are used for primary distribution. Let's begin with the next category. The next category is the high voltage category. The voltage starting from the 69 kV to the 345 kV is known as the high voltage line, that is HV, and it is used for the secondary transmission purpose. Okay, then the next category is the extra high voltage, EHV. We are going to see this unit in detail in the next module. Okay, so extra high voltage, that is EHV. So that voltage lies between 400 kV to 800 kV. So if we take the example of Maharashtra, we have a 400 kV transmission line between your Kalwa substation to Lonikan substation, which is near Pune. Okay, and then again it is going towards the Vidarbha side from the Kalwa, which is in the Thane, and from this is going to the Lonikan side. Okay, so this is the extra high voltage, but we have not stopped on this voltage level. So India is planning to go beyond this 800 kV also. So we are that category is known as the extra high voltage, ultra high voltage, that is a UHV. Okay, and that voltage level is above 1000 kV, that is also used for the primary transmission. Okay, so India is planning for the voltage level of 1200 kilovolt. What are the benefits of going for the 1200 kilovolt or high voltage UHV and UHV line, that we will see in the next module. Okay, so but please remember that India is going for the 1200 kV, and the first line is going to be installed from, okay, Aurangabad, which is in the Maharashtra, and it is going to the Bina, which is in MP. Okay, so from the Maharashtra to MP, this transmission line is going to be installed soon. And for the testing of this material, that laboratory is also is in India, which is developed in the Nashik. At the Crompton Graves. So 1200 kV testing lab is also available in India, which is the fourth lab in the entire world. Okay, fourth lab in the entire world. Okay, so we have achieved this voltage level in India also, 1200 kV. But classification of the transmission line for the voltage level, it's okay for understanding for our transmission level voltages. But while going to the modeling, when we are going to analyze our transmission line, it is not sufficient only the voltage level. So according to length, the transmission lines are classified as the short transmission line, medium transmission line, and long transmission line. Okay, so what are the lengths? The length which is below 80 kilometer are coming in the category of the short transmission line. The length between 80 kilometer to 200 kilometer is in medium transmission line, and above 200 kilometer it comes into the long transmission line. So for that, what are the voltage level? Generally, short transmission line is preferred the voltage level below 20 kilovolt. Voltage level below 20 kilovolt. Between 20 kilovolt to 100 kilovolt, medium transmission lines. Okay, so for 80 kilometer to 200 kilometer, we can prefer the medium voltage level. And for the long line, suppose the power is to be transmitted beyond 200 kilometer length, then voltage level must be greater than 100 kilovolt to get a good benefit. Okay. So let's begin with the remark. Okay, so we know that in this case, the short transmission and neighbors indicate the length is short, voltage level is also less. As the voltage is less and the length is also less, so between two conductors, the charging current, okay, so the current which is flowing from the shunt capacitance, which is known as the charging current, that charging current is very low. Okay, so the charging current is very low because it will form a large value of Xc, that is C is very low but Xc is very high, so that the less charging current. Hence, but in case of medium transmission line, it is having the significant length as well as it is having the significant voltage level. So we have a significant charging current. So charging current need to be considered when we are considering this. Then high length, in the long transmission line, the length is also high and voltage is also high. But here the parameters cannot be lumped. In these two cases, we for analysis purpose we can lump the parameter. But in the long transmission line, we cannot lump the parameter because length is also high and the voltage level is also high. Okay, so for a modeling purpose, in the short transmission line, R, L are lumped and C and G are neglected because the charging current is less, the effect of the capacitance and the conductance is neglected. That means only series elements are corrected, and that to the what? That to the series element are considered as the lumped element. The series elements are considered as the lumped element. In this case, G is neglected, medium transmission line, G is neglected, but RLC is considered. Okay, RLC, but the parameters are again lumped. Means the parameters are distributed over the entire length. For analysis purpose, we can lump that parameters. Okay, we can lump that parameters. Okay, so likewise we can lump this parameter. But in case of long transmission line, we cannot lump the parameters. We have to consider R, L, C, G, all parameters. Okay, so that is resistance, inductance, capacitance, and conductance. All parameters must be considered in the transmission line. In this case. Okay, so let's begin with the reflection point. I'm going to give one question over here. You have to pause the video for some duration, and you have to check your knowledge whether you got that knowledge or not. Okay, so this is my question one. In a short transmission line, the effect of shunt capacitance and shunt conductance is neglected due to. Okay, so options are short length of line, less voltage level, less charging current, all of the above. So pause the video for some duration and answer this question. Write down the answers on your paper. Okay, and then we will check what is the answer. Okay, hope you have solved this question. So why the capacitance and shunt conductance is neglected? It is having the short length, it is having the less voltage level, it is having the less charging current. Means all answers are correct, hence option D is your correct answers. Hope you got the correct answer. Let's clap for you. Okay, let's clap for you. Yeah, you got the correct answer. Okay, sure. Next, okay, sure. Let's move further. Okay, this is the second question for you. A transmission system with the voltage of 400 kV is high voltage level, extra high voltage level, ultra high voltage level, medium voltage level. Pause the video for some duration and answer this question. Okay, hope you have answered this question. As I discussed in the earlier slide, the voltage which is for the 400 kV, it comes in the category of EHV transmission line. Up to the 345 kV, it is in the HV category. About the 400 kV, 400 and 400 kV above, it is in the extra high voltage category. So hope you got the correct answer. That is, in this case, it is a what? Extra high voltage. So the correct answer is what? Your B answer, extra high voltage. Okay. So let's come to the next. Let's come to the next slide. Let's summarize all the points together. From the discussion, we clear that the transmission system is a key element in the electrification system because it needs to transmit the bulk amount of the power from generating station to the load centers. R, L, C, G are the parameters of the transmission line which are distributed over the entire length. According to the voltage level, the transmission lines are classified as LV, MV, HV, EHV, and UHV. Low voltage, medium voltage, high voltage, extra high voltage, ultra high voltage lines. According to the length of the transmission line, they are classified as short transmission line, medium transmission line, and long transmission line. Okay, so out of these four parameters, R, L, C, G, C and G are neglected in the short transmission line, and R, L are the lumped. In the medium transmission line, we are considering the R, L, C in the lumped form, but the G is neglected. In the long transmission line, we consider all parameters R, L, C, G for the analysis purpose, and again these parameters are the distributed. So in this both case, it is a lumped, it is in a long transmission line distributed. Okay, so for analysis purpose, how we analyze the transmission line using the two-port network, that we will see in the next video. Okay, hope you enjoyed the today's video and you got the whatever we discussed in the learning outcomes. You got all the classification of the transmission line. Thank you. Okay, have a nice day.